So here we will see the order of the system. So for input, excitation, and for response output, by using a differential equation, we can represent by using this equations P of t and Q of t. So that is here Q of t is called as excitation and P of t is the um, response. So then now we'll call this equation as 1 and we can represent this equation 1 by using Laplace transform as P of s divided by Q of s. So that is the transfer function of that above equation is P of s divided by Q of s is B naught s to the power m plus b1 s to the power m minus 1 and so on divided by a naught s to the power n plus a1 s to the power n minus 1 and so on up to n. So from the denominator of the polynomial, so that is equation 2, from the denominator of equation 2, we can write the order of the system. So that is, in the denominator it is a naught s to the power n. So from there, if the value of that s to the power n, there n if it is equal to 0, then we are calling that system as a zeroth order system. If that the value n is equal to 1, then we are calling that first order system. If n is equal to 0 or 2, then it is a second order system and so on. And we can write this equation, numerator and denominator of equation 1 or equation 2 can be written in factorized form like this. So that is T of s is equal to P of s divided by Q of s is equal to s plus z1 into s plus z2 up to s plus zm divided by s plus p1 into s plus p2 so on up to s plus pn, where numerator z1, z2, z3 are three zeros of the system and denominator p1, p2, pn are the poles of the system. The value of n in the equation 2 denominator a1 into s to the power n. So there the value of n gives the number of poles in the transfer function, and hence the order is also given by number of poles in the transfer function. So we can identify this order by from the poles of the system also. So next we will see the derivation for response of first order system for the unit step input. Response of the first order system for unit step input. So we'll consider now first order system and we'll take input R of s as unit step input and we'll find out the output in time domain. So we know that the closed loop first order system with unity feedback shown in figure 1. So that is the figure, it is a closed loop con control system and our input is R of s and forward path gain is 1 divided by t s, because now 1 divided by t into s is s to power 1, so it is a first order system. C of s is the output and it is a unity feedback 1. So now if you want to find out the transfer function of this, that is C of s divided by R of s, we know it is a closed loop system, it is g divided by 1 plus g into h. So here g is 1 divided by t into s, h is 1. So we will get 1 divided by, after the simplification, we will get R of s into that forward path gain is 1 divided by 1 plus t into s. So I can write the transfer function C of s divided by R of s is equal to 1 divided by 1 plus t. Yes, we call this equation as 1. Now we'll take unit input as unit step function. So that is u of t is equal to 1. Unit step input u of t is equal to 1. The Laplace transform of that is 1 divided by s. So then I can write input R of s is equal to 1 divided by s. Call that equation as 2. I will substitute this into this input in the first equation. So that is C of s is equal to 1 divided by 1 plus t into s into r of s, or C of s is equal to 1 by 1 plus t s into r of s is 1 divided by s. So now just write multiply this one, that is C of s is equal to 1 divided by s into 1 plus t into s we will get. So now we have to apply, this is the output in time in s domain we got. So that is C of s. Now we have to find out the response in time domain. What we have to do? We have to apply inverse Laplace transform. So that is for the to apply inverse Laplace transform, we have to rearrange this equation. So we have to keep in standard form, then we can apply direct formulas. So that's why I have to take here. I have to take t outside. So I will write it will be 1 divided by s into t into 1 divided by t plus s. Or I can write rearrange this equation as 1 divided by t divided by s into 1 by t plus s. Now how to simplify this? It is partial fraction. You have to apply partial fraction, you know. So that is C of s is equal to our 1 divided by t divided by s into s plus 1 by t is equal to, I can write a divided by s plus b divided by s, another function s plus 1 by t. So now we have to find out, we have to cross multiply, and we have to find out the value of a and b that you know studied in first year. So that is a is equal to, we'll get a is equal to 1 and b is equal to minus 1. So we have to put s is equal to 0, we'll get the a value. So then we'll get the C of s is equal to 1 by t is equal to 1 by s plus minus 1 divided by s plus 1 by t, or else I can write C of t is equal to inverse Laplace transform into 1 divided by s minus 1 divided by s plus 1 by t. So now we know we have standard. Now we'll get we can write, we know the standard Laplace inverse Laplace transform is 1 divided by s plus a is equal to e to the power minus a into t, or e to the power at is equal to 1 divided by s minus a, or 1 divided by s plus a is equal to e to the power minus at. 1 divided by s minus a is e to the power at. Now the first function is 1 by s, so Laplace inverse transform is 1. Second function is 1 divided by s plus 1 by t, so it is 1 divided by s plus a. So that means e to the power minus a into t. So here a is 1 by t, so that's why finally c of t is equal to 1 minus e to the power minus of 1 by t into t. So call this equation as 3. The response of the closed loop first order system for unit step input is this one. So now we can and this is step input of step value a. I can write this equation 3. I have to multiply with the a, and we will get the step response is equal to a into 1 minus e to the power minus of 1 by t into t. Now I can find out the values for substituting t is equal to 0 to some values, and if t is equal to 0 I will get response C of 0 is equal to 0. If t is equal to 1t, then I will get the value C of t is equal to 0.632 and so on, and in till infinity we have to find out the values, and then C of t with respect to t I can plot. So we'll get this type of curve.